You are going to watch about the first helicopter named Ingenuity that will fly in the next door neighbor planet Mars.
It released another rover named Perseverance, which almost looks like Curiosity rover, but the technology is very advanced. The helicopter Ingenuity is kept in the underbelly of the rover. You might be wondering, how can a helicopter fly in a world that only has 1% of the Earth's atmospheric pressure?
NASA found a logical solution that if you reduce the mass of the helicopter and increase the speed of the rotor, you can actually make your helicopter fly in a Martian condition. In planet Earth, a cubic meter of air is about a kilogram. Same cubic meter on Mars will be about 16 grams. The propellers needs to be fast, a very higher rate than the global drone. The blades spin at the rate of 2500 rotations per minute compared to the regular drone rate of 500 rotations per minute, and it pushes a lot of air down to fly.
Amazingly, the helicopter weighs less than a 2-liter water bottle.
The helicopter has 4 legs, a box with a processor, propellers made of carbon fiber with 1.2 meters in diameter, antenna and a solar panel. Processor board used is a Snapdragon 801 manufactured by Qualcomm. It's a cell phone class processor and the board is very small but modern technology. It's vastly most powerful than the processors that are flying on the rover. The drone uses Linux operating system because it's an open source operating system and an open source flight software framework.
It's kind of an open source victory.
In order for this to work, Ingenuity has to survive freezing temperatures range from minus 80 Celsius to minus 100 Celsius. It has to manage power restrictions and attempt a series of 90-second flights while separated from Earth by 10 light minutes, which means the real-time communication or control is impossible. It flies about 30 to 90 seconds at most.
Putting a drone on the surface of the red planet will be useful for exploring missions. Although we can record Mars from space, getting a closer look what lies ahead will be useful for future rover missions. NASA thinks the ability to see further ahead will actually allow rovers to move across the surface of Mars much faster.
In the past, the Little Rover Opportunity was last in June 2018 and officially announced dead in February 2019. It covered 28 miles over 14 years. Rovers have to move slowly with the NASA engineers on Earth feeding commands that could take 10 minutes to get to Mars, so carefully planning the route for a rover is important. Imagine having a support by a helicopter that would allow Mars rovers to roll further than ever before and at a much faster pace. In addition to that, NASA's rovers can't get everywhere. They are built like cars, and if they want to get up to the rocky surface or the side of a mountain, they have no chance. But a helicopter can do that. And when humans go to Mars, these helicopters are very valuable in future exploration and guidance.
It's important to keep the Mars helicopter mission in situation because this is a technology presentation. The main goal here is to fly on Mars, full stop. It will be Wright brother moment on Mars. Ingenuity won't be doing any of the same sort of science that the Perseverance rover is designed to do. One advantage of flying on Mars is that gravity is only 38% of what it is on Earth. Min Young, born in 1968, is a Burmese-American engineer and project manager at Jet Propulsion Laboratory. She is a lead engineer on Mars helicopter Ingenuity, the first extraterrestrial aircraft. Bob Balaram is the chief engineer for this project in Jet Propulsion Laboratory. He is from South India. He did B.Tech from Indian Institute of Technology, Madras, and remaining studies from America. He is responsible for the technical design and integrity of the project. Perseverance collects samples by drilling in the surface of Mars to get a small piece of rock and bring them to Earth.